A 4,000 kilogram truck is parked on a 15-degree slope. How big is the friction force on the truck? The coefficient of static friction between the road and the tires is 0.90. So the first thing we want to do for this problem is draw what is given to us. So it's a 15-degree angle. So I can make a triangle here. And I can make that 15 degrees. And then a truck, I'm just going to make a dot because I'm not artistic. All right, so if this is our picture. So with this, we can make a free body diagram. So here's our object, circle, circle. So gravity is moving down. Gravity is right there. Normal force, it's perpendicular to the surface it's on. So normal force would be this way. And then there is static friction, and static friction is keeping it from sliding. So static friction is going this way. So F of S, because static friction, normal force, gravity is mg. Okay, now with this, we want to make a coordinate plane for this. Since it's at an angle, it is best if it is like this, where this is the x-axis, this is the y-axis. Okay, so according to Newton's second law, force is equal to mass times acceleration. So now with this, we can do this. We want to find the static force coefficient. So what we have to do is find F net, because that's how we find the static coefficient. So now, this would be easy to solve, but except it's at an angle here. So we need to find what trig identity we need. So this is SOHCAHTOA. So we need to find whether it's sine, cosine, or tangent rather. So the way we can do that is this. Let me see if I can get on the camera there. Okay, so I'm just going to draw this triangle, but a little bit larger. So it's easier to see what I'm going to do. So here's the truck. It's a dot, but you know. So now I'm just going to draw the not normal force, the angle that it would be going if it was, if it's perpendicular to the hypotenuse, and then the line here, if it's going straight down. So this would be our theta. Now this smaller triangle and this larger triangle are identical. But just to make that even further, I'm just going to say these both are 90-degree angles, and this is also 90 degrees because it's perpendicular to this line. So we can conclude, since that triangles have to equal 180 degrees, we can conclude that this angle right here is 90 minus theta. And then we can conclude that this angle is theta. So now we want to find what trig we should use. So if we're looking at here, and then we also need to find if it's going down the slope. So it's, well, we can do opposite over adjacent because that is where it is sliding down. So in this problem, we will use sine. Okay, so now we know that we're using sine. We can do force equals mass times acceleration. So we could do, well, F net equal to force equals mg sine theta. Yep, and then minus the static coefficient. So we could do mg sine, I'm just gonna leave it theta for now, just to keep it abstract, minus friction static. And the reason why this is subtraction is because all of them are going in the positive direction, and this is the only one that's going opposite of where it's going. So that's why this is subtraction. Okay, so force equals mass times acceleration. But as you see, in the problem, it's saying it's parked, and that the static coefficient is 0.90, meaning that the acceleration is 0 because it's not accelerating, because it's not moving. So we can say that this is 0 equals mg sine theta minus static friction. So we want to find the coefficient of static friction. So using algebra, we can bring it to this side if we add to both sides. So f of s equals mg sine theta. So now, do we have everything to solve for static friction? We do. We have mass, which is 4,000 kilograms, times gravity, which is 9.8. Well, let me do this. Well, 4,000 kilograms times 9.8 meters per second. And then sine of 15. And you want to have your calculator in degrees, equals Fs. And when you multiply all of these together, you get that Fs equals 10145.7 newtons. And there's your answer. Two balls in figure 2.7 are sliding down the incline. What is the tension of the massless string? All right, so for right now, this is the picture where the incline is 20 degrees. Block 1 is 1.0. The tension is what we're trying to find in the string there. And block 2, which is the mass of 2.0. The kinetic friction of block 1 is 2.0, and the kinetic friction of block 2 is 0.10. So now I already drew the free body diagrams. It's pretty straightforward, where gravity is always pointing down, the kinetic friction is going in the opposite direction to where it's going, normal force is perpendicular to the surface. The only difference between these two is that tension are opposite, because in block 1, tension is pointing down, where block 2, the tension is going against to where it wants to go. So now what we need to do is find F net. So now, how to do that is we need to find the kinetic friction. So F kinetic friction is equal to mu times the normal force. And let's find this for block 1 first, so I can label this more. So now, we already know mu, we do not know normal force. Now, normal force of block 1, is equal to mass times acceleration. And since it is at a incline, we have to add a trigonometric function to it. So now in my last video, I explained how we get those, whether to use sine or cosine or tangent. And in this case, it is cosine of theta. So now we can use these two equations, where Fk of block 1 equals mu 1 times ma cosine of theta. Beautiful. So now we can find Fx net, F1 of net is equal to mg sine of theta, and this is net for it. So this is everything that is going in the positive direction, and then we are going to subtract what is going opposite of. G sine theta plus tension of the first one minus, and then we're bringing in the friction for it. So this is mu of 1 ma cosine of theta. Beautiful. So now, in Newton's second law of forces equals mass times acceleration, so this is ma equals mg sine theta plus t minus mu ma cosine of theta. Beautiful. And now the only unknown that we have is acceleration. So what we need to do is solve for acceleration. So we can just divide all of this by mass, and that will get us acceleration equals mass of 1 g sine theta plus tension minus mu ma cosine of theta divided by mass. So now, block 1, as you notice, is 1 kilogram. So what we can do is just plug in the numbers for it. Numbers that we do have. We're still trying to find tension, so that is still our unknown. But our acceleration equals, and we just plug in everything that we know. So that is 1 times 9.8 times sine of 20 plus tension minus 0.2 times 1 times 9.8 times cosine of 20. And this is all divided by mass 1, which is 1, so I'll just do that. So now, if you do the math for this, for brevity's sake, I'm just going to write down what it is, which is tension plus 1.51 meters per second squared. So now we have that, let's try to solve for block 2. So block 2, I'm going to do almost the exact same thing to get the friction force, but this time we have an unknown of acceleration. So I can do, for block, I'm just going to write that block 2. So what I can do is do the normal force of block 2 equals mu 2, normal force is equal mass times acceleration of cosine theta, and then the friction force K equals mu 2 of n2, and we can use these two equations to get this final equation of F, K squared equals mu 2 ma cosine of theta. Beautiful. So now I'm going to do almost the exact same thing. We're trying to find F net now. I'm just going to sub in ma because of the Newton's second law. So I'll just say mass times acceleration equals and literally the exact same thing. We're just going to get everything that's in the positive direction to where it's going, and then subtract what is going opposite of where it's going. So ma equals m2g sine theta. And now I say it's almost similar, but you realize that in block 2, the tension is opposite to where it's going. So in this case, it is minus tension, and then multiply mu 2 mg cosine theta. All right, So now we're trying to find tension. So we're just going to do some quick algebra and just bring tension over here and MA over here. So now this would be tension equals M2G sine theta minus MA, because you brought that over there, minus mu, I'm sorry, that's supposed to be a subtraction sign, mu 2 mg cosine theta. All right, so now we can plug in all the numbers. So tension equals 2.0 kilograms. I'll just add in the units. 9.8 meters per second. Sine 20 minus 2. And then we found acceleration, which is t plus 1.51 mu, which is mu of 2, which is 0.10, then 2.0 kilograms times 9.8 times cosine of 20. All right, and then when you do all the math for this, when you do all the math for this, you get tension equals 0.613 newtons. All right, and the one problem that I see a lot of people have, including myself, was that you need to distribute this and then you will get tension. All right, and that's how you find the tension of this massless string. Two wires are tied to a 300-gram sphere shown in figure 8.46. The sphere revolves in a horizontal circle at a constant speed of 7.5 meters per second. What is the tension of each wire? So now, this is our picture right there, and I'm going to draw the free body diagram. This is tension upper, and this is tension lower. Let me just do that back. Yeah, beautiful. Tension lower, and then gravity of mg. So now for these questions, I want to split up fx and fy, which is forces of the x direction and then f in the y direction. You'll see in a minute why it is much easier to solve these questions for that. So now, f in the x direction. This is, let's see, in the x direction, I'm keeping the coordinate plane regular for this purpose. So f in the x direction, you see that the tensions are in there, well, in the x direction. And you also notice that it's not a perfect 90 degrees, so we have to add a trigonometric function to this. Now in the previous videos that I've shown why I would choose cosine in this question. So in the f direction is tension upper cosine of theta plus tension lower cosine theta equals, and then if you've seen the question, it is saying it's revolving in constant speed. So we could say that the force is equal to mv squared over r. And now you see that there's cosine in each of these, so we can actually rewrite this if we factor out a cosine theta over tension upper plus tension lower equals mv squared over r. Beautiful. So now what we can do is we want to find what theta is. So if we use trig, we can see that theta is here for both of them. And we can see that this is opposite and this is hypotenuse. Now, what trigonometric function is opposite and hypotenuse? That is sine. So we can see that sine of theta equals 0.5 over 1 or 0.5. And we want to isolate theta, so we can say that arc sine of 0.5, I'm just going to leave out the divided by 1 because it's going to be the same thing, equals 30 degrees. We should say that. So now for our purposes, we can use cosine of 30. So cosine of 30 equals square root of 3 over 2. All right, so now we have theta. So now what we need to do, well, what we need to find now is the radius. So now, I'm sure that you know where this is going with Pythagorean's theorem. You know, a squared plus b squared equals c squared. Well, we already know c, and we already know a, so we need to find b squared. So that would be b equals, and then to get rid of the power, we can just do a square root of c squared minus a squared. That c squared is the hypotenuse, which is 1. You see in our problem there. And then a squared is 0.5. So if you plug in 1.5 here, b is, well, if you plug it in, is 0.86 meters. And that is our radius. Beautiful. So now we can solve this if you just plug in all the numbers. So now we can just do this. Cosine of 30, I'm just going to write it as square root of 3 over 2. We still do not know our tensions, so tension upper plus tension lower equals, and now everything else is known, which is 0.3 kilograms. I just 300 times 1 over 1,000. Yeah, and then is 0.3 kilograms is equivalent to 300 grams. Let me say that. Velocity is given 7.5 squared divided by our radius, which is 0.86. And when you do that math to isolate our unknowns, which is tension upper and lower, you solve this and then you divide, is equivalent to 22.657. That is our tension upper and lower. So now we have found this in the x direction. Now we can find this in the fy. So now in the y direction, we will use sine theta, which and we already found theta, which is 30. So I can just write sine theta, which is 30. We found the previous, equals 1/2. So now we can find that tension upper minus tension lower. Well, sine 30, which is 1/2, equals ma. Because it was revolving in the x direction, and the y direction is not moving, so the force is going down, which is mass times acceleration. Mass times acceleration equals a force due to Newton's second law. So now we can just find this. So this is tension upper minus tension lower, 1/2 equals mass 0.3 times the acceleration of gravity, which is 9.8. Because it's rotating it's rotating constantly, and since it's not moving in the y direction, the only thing that's pulling it down is gravity in the y direction. Which, if you do the math, you just solve this and then divide by half, you get 5.88. So now something special happens with these tensions. You see that tension in the x direction, upper minus tension lower, equals 22.657. You can actually add these, and tension upper minus tension lower equals 5.88. And then you can actually see how these cancel out. So that is 2 tension upper equals, and then you can add these, which is 28.537. Divide by 2, divide by 2. Tension upper equals 14.268 newtons. And then you can just you can plug this into either of these and then solve it. So then tension lower equals 8.388 newtons. All right, and that is the tension of this wire and this wire.